Welcome to the Human Factors and Ergonomics Hub, a series of educational podcasts that showcase the connection between human capabilities and good work design, brought to you by the Human Factors and Ergonomics Society of Australia. Dr. Christopher Reid is a technical fellow and Boeing designated expert in both human factors and ergonomics and wearable technologies. He is based out of Charleston, South Carolina, USA, and is the current technology architect for the Boeing's Environment, Health and Safety Organisation. Prior to Boeing, Dr. Reid worked for Lockheed Martin as an astronaut spacesuit assessor and as a human factors and ergonomics discipline lead at NASA Johnson Space Center as a human factors engineer for the US Army NATEC labs, assessing warfighter personal protective equipment. He is a fellow and past president of the HFESA and current chair of the ATSM subcommittee on human factors and ergonomics for exoskeletons and exosuits. Dr. Christopher Reid is a keynote speaker at the Human Factors and Ergonomics Society of Australia's conference in Adelaide, November 23. So, Chris, tell me a little bit about yourself, how you became interested in human factors and ergonomics.
Yeah, so it's almost like every time I talk to people about this question, I find out I'm not the only one who kind of stumbled into human factors and ergonomics. It almost feels accidental. But I started after I graduated. So I graduated with my undergraduate degree in electrical engineering. I focused on database and data analytics capabilities. So I started heavy on the computer side as a computer systems engineer was my first job. I was working for a company called CAFM, Computer Automated Facilities Management. And as you can imagine, they made software to maintain buildings. And we were working on the systems interface, and I was trying to figure out, what are better ways to do this so they're more user-friendly. So I went back to school. I graduated out of the University of Central Florida in Orlando, Florida, and it was in vicinity of where I worked. So I went back, look for some classes. Hey, what could I do to give me an edge on software development? Took classes in usability and in human-computer interaction. And that's when I started realizing, wait, there's a bigger world out there in human factors and ergonomics. Well, as fate seems to control or God or the universe, whatever you want to call it, unfortunately, I got laid off because, the company was cutting back. And I was already in school, so I said, why not? Let me go ahead and turn this into a full-fledged set of degrees. So I did a master's in industrial engineering and engineering management, and then a PhD in industrial engineering and human factors and ergonomics. And that's where I continued to spread beyond just human-computer interaction and the computer side. I went more into systems interaction in general.
And I believe you're working with Boeing, rather. So what are you doing there?
Yeah, so Boeing is an interesting take. So that was my first practical, I would say, application of human factors while I was still in school. I actually was finishing my ergonomics coursework. We were doing capstone activities, and I got tied into Boeing at Kennedy Space Center in Florida. Because, it's right there where the University of Central Florida is. And so the job that I got exposed to was the ergonomic evaluation of the Leonardo space module that ended up being on the International Space Station. So it's almost like, we're just going to drop you right into the deep end and we're not going to try and spin you up. And so here was, with the team doing ergonomics evaluations on how they moved the module around, how they inserted the laboratory sections inside the module, because just like anyone who's seen those videos from space, there is no up and down. Everything can be left, everything can be right. It's a giant cylinder that you're in, a giant tube. And so you have all these experiments going 360 degrees around. You just kind of spin yourself to where you need to be. And that's your, what you're focusing on. And so when you're in a gravitational environment like on Earth, putting something in the floor is not as easy, or putting something up in the ceiling is not as easy. And so this is where the ergonomics, at least on Earth, was kicking in. And it was a really interesting take on, this is what ergonomics or human factors is like. We're trying to prevent musculoskeletal disorders. And that was where I first started. And so after that, a couple of years later, I applied for an internship with Boeing in Seattle. I applied to 2 jobs, actually. One was for flight deck, and that's to do the instrumentation stuff. And then the other was for the manufacturing side, for ergonomics, shop floor ergonomics. The shop floor called me first. Flight deck called me a week later. And I had to apologize to flight deck because I already accepted the previous position. But, I always wonder, what would my life have been like if they called first? Would I be flying around, working flight controls? My life would be a different take on human factors and ergonomics. But that's where I got my first start in the Boeing company as a graduate intern. 3 internships, and, years later, it's been a fun ride.
Wow, I didn't realize that you'd been with them so long, but what a fabulous beginning. I mean, who gets to work in space on their first job?
Yes, it was completely, it was a geekifying moment, so to say. I grew up on watching a lot of science fiction, as many are. Star Wars, Star Trek, all that stuff. Most folks tend to see that floating behind me. Sometimes the USS Enterprise. It's completely been a part of my life, with the fascination with aerospace, the fascination with space. So I'm glad I had the chance to work in the space industry.
Fantastic. So what kind of projects are you working on these days?
So nowadays, I tend to primarily be focused on technology that can be used to improve safety and performance for the manufacturing side of the house. So there are about 200 plus human factors ergonomics professionals in the company. And each of us are spread across the life cycle of what you can imagine the company makes. Many are on the design side, many are on the build side. Then you have the operations side and working with customers. And then you have the maintenance side. And so I'm on the manufacturing side of the house, working in production. And then I also help on the maintenance side. So I sit as a technical fellow for human factors and ergonomics. I also cover safety. I mainly focus on technology and how technology can be designed and implemented into the field. And so my primary function at the moment is the head of the exoskeleton program for the company, and other wearable technologies that we can use in the field. So I would say exoskeletons consume 80% of my life, and the other 20% are on consulting for the company for human factors and ergonomics needs, and then other technology needs.
So the interest in wearable technologies, was this, and the exoskeletons, was this to address the manual handling problems you were having in manufacturing?
Partially. If we think of the hierarchy of controls, what we're always taught as safety and ergonomics practitioners, you try and get rid of that hazard altogether from the beginning. And then you roll down through engineering and administrative controls. And at the bottom, you have personal protective equipment. So we kind of see exoskeletons at the bottom. We have many human factors and safety and ergonomics practitioners who sit at the front end. So as a new product is coming online, their job is to remove the hazard before it even comes into the picture. And then you have folks who sit on I guess we call it the legacy side of the house, the existing product manufacturing processes, and try to continuously squeeze out risk and squeeze out hazards from an existing system. And so I sit on both ends and advise and help on both ends. And this is where the exoskeleton kicks in. If we know there's a hazard that we completely can't eliminate, for example, like working overhead, I like to say, unless we're growing aircraft in cornfields and they're building themselves, or we're manufacturing them underwater or in space, gravity still applies. Putting your arms up still counts, and just that alone is a risk. And so we haven't figured out how to get rid of that hazard yet. And if you got one, let me know. But it's something that's inherently part of the build process. And so PPE is just part of that picture of solutions, of options.
So what kind of exoskeletons are you using? You've obviously mentioned upper limbs, but tell me about the different exoskeletons you're using and where you're using them.
Yeah, I want to say there's a company called exoskeletonreport.com. They tend to survey what's happening globally for exoskeletons. And last I checked, there were around 170 different types of models of exoskeletons globally. And of course, that's always growing or shrinking depending on how the ecosystem changes. And typically when you get into the exoskeleton space, you're either in the medical space looking at rehabilitation exoskeletons, or there's a small military segment where you look at how you can help it with operations for warfighters, or on the industrial side. And I sit on the industrial side, obviously. Within the industrial space, you have exoskeletons that are for postural assist, like awkward postures. You have ones that we call the supernumerary arms. They're like the science fiction Dr. Octopus with multiple arms of exoskeletons. And then you have the strength assist. I call that the unicorn series because we're waiting. We're hoping there'll be an Iron Man in the future, but it just hasn't come to bear fully materialized as yet. And so where we are primarily right now in this day and age is the postural assist space. And you have that broken down by, let's say, body segments, hand posture assist systems. You have lower back, shoulder, knee. Sometimes they can pair together. Some companies allow you to put on different segments at a time, like to help with the shoulder, back, and knee at the same time. But it's primarily, I would say, an anti-fatigue device to help with a portion of the offload versus a full offload, like maybe a full strength assist system.
Does one exoskeleton fit everybody, or how do you manage anthropometrics?
Yeah, that's a hard one. Working on the standard side of the house, so as you or other folks may know or may not know, I sit as the subcommittee chair for ASTM International Standards Body, and F48 focuses on exoskeletons, and F48.02 is on human factors and ergonomics and safety, and that's where I chair. So we produced about 7 different standards for human factors and ergonomics. Overall, the committee has produced about 24. I think it's 23 last I counted. In particular, right now, we're working on an anthropometry standard. And specifically for, how do companies design for an end user, for a consumer? And you have to be very specific with how you're targeting the population. So this exoskeleton is designed for senior citizens. This one's designed for men, this one for women, this one for children. Just like any other, wearable device, clothing, you have to understand your customer. And so what we're basically saying is, look, there are these large publicly available or privately available data sets. This is how you pick and choose the correct types of metrics, the lengths, the widths, the circumferences, and understand who you're designing for. Once you understand that, then you can figure out within those confines how you expand or shrink to the population that you're focusing on. But what we're having a hard time, and we're starting to make inroads on is, how do you teach people how to design for people? It sounds simple. Hey, I'm human. I know how to design for myself, but that's the problem inherently. You're designing for you versus, I'm designing for Sharon. And that's what we're trying to teach people. It's a little test of empathy to understand who your population is and design for them specifically.
So given that you have problems with anthropometrics and people's body size and shape, how are you managing the exoskeletons at the moment?
So at Boeing, we use a qualification process. It essentially involves understanding anthropometry size and shape, because we have a huge variety of people. We're talking our population somewhere around 150, 160,000 people. Of that, you have a subset that are mechanics working on producing the products, somewhere in the neighborhood of 50,000 people. So you just don't know who you're going to design for. And it's constantly changing because people are leaving and people are coming in. And so what we like to say is we try to design for the 90 to 95%. That broad spectrum. You're never going to perfect and get to 100%, but if you can capture this, you're good. So what we do is we bring them in and we say, okay, what are your adjustment ranges? What parts move? What parts change? What parts do I need to be concerned about? We put it through a anthropometric analysis, like, we might use, they call it ANSWER, the anthropometric survey that came out from the US military, or we might use CSER, which is out of the European side of the house. We use these different data sets to understand how well does this accommodate for the breadth of our potential population? And once we hit that, then we say, okay, anthropometry check. Now let's test the usability. Usability looks good. How does it interface with the person? How does it interface with the environment? How is mobility constrained or improved? These are all different categories. Biomechanics is another category. Safety, is it going to scratch a person or get caught in a machine? You try to capture this massive list of check boxes. And once you get through all of that and you qualify the system, hopefully by the time you put it out there, it's still, people acceptable. I would say that's the hardest part. It's user acceptance, even after all of the stuff you go through with, weeding out the bad ones and keeping the good ones.
So what's your user acceptance like? I mean, if it looks like Iron Man, they're going to think it's pretty cool to start with. But when they're working in it all day, maybe not.
Yeah. User acceptance is up and down. I like to say it's always half and half. As soon as you convince someone this is, the next thing, the best thing next to sliced bread, someone else is like, I'm not that impressed. And so it's always changing. I think it's the fragility of human nature. You're continuously having to convince the next person that this is a good thing. It benefits their use. We've proven it out on the biomechanics, the risk reduction, the usability, all that stuff. I like to refer sometimes to, one user that I got a survey from. We continuously survey what's happening out there. And it was, okay, now, how do you perceive the exoskeleton? Is it useful to you? Oh, yeah, it's quite useful. But then on the other side, you ask, okay, so what's your intention of using it? Oh, I'm not interested. And then you try to whittle that down to, okay, where's the why? What can we change? What can we adjust? And it varies by person to person, but I think inherently people just don't like to put on anything that they perceive as an impedance. It could be a hard hat. It could be safety glasses. It could be fall protection. Anything that's seen as potentially getting in the way of the work or, causing heat or being itchy or, working into the creature comforts of people, they see that as a barrier. And so the hardest part of all of us as experts in human factors and ergonomics is to weed out the things that you can control. And for those small amount of things that remain, trying to understand the socialization, the psychology of human nature and what else you can do. But we know we're never going to hit 100%. So that's one thing we've had to accept. The compliance of constantly going to change, and hopefully over time it continues to increase.
So have you made it optional so that some people can use it and some people can choose not to? Is that?
Yeah, so it depends on the program. We've allowed programs inside locations to pick and choose and do as they wish. So the option is there. If you want to have it optional, people can pop them on, use them whenever they want, and if they leave, maybe their successors may or may not use them. Then there's other programs that we're trying where it's mandatory. Obviously, we don't invest in exoskeletons in areas that have low risk. We look for the highest risk, the highest hazard areas, and focus on those up front. We have somewhere in the neighborhood of about 400 shoulder exoskeleton units across the United States in different sites and locations. And we've primarily been using injury data and risk data to drive us where do we deploy them, essentially. And so, again, it comes down to, the end users. What would they like to do? And option versus mandatory is a choice.
So where are you getting the best result?
It's hard to say. So one of the things that we've had to deal with is turnover. Because as you can imagine, coming out of the pandemic, the supply chain, everything was in chaos. And so we are still in a set of programs that are constantly shifting to those changing supply chains, and rates are going up and down. And so because of that constant turnover, the hardest part for us is maintaining sustainment of the systems in the field. So as soon as I deploy 10 units out there on 10 different people, they may be gone 3 months or 6 months later, and I have to go convince 10 new people that this is the right thing for them. And so that constant churn is one of the things that we're having to contend with right now. How do you create a sustainable environment? I've even asked many of my peers, how do they do it? And it's a really, I would say this is the undiscovered country at the moment for the technology. Deployment isn't the problem. We know how to target. We know how to apply. It's how do you sustain with a constantly changing population? And that's where we are at the moment. We have had environments where we've had the systems out there up to a year. And in those environments, we've seen not just risk, because risk you can calculate up front. We've seen injury numbers decrease in those environments. But it's sustaining beyond that. That's the hardest part. I think many of my partners out there in the industry will be facing the same thing if they haven't already.
Is it cost effective?
I would say the cost of the units are coming down greatly. So the passive devices tend to be on the cheaper side. You're talking about springs or bands, or basically using passive and active energy using mechanical-based design. And so those tend to be on the lesser end. In the US dollar value, you're talking about single-digit $1,000 devices. On the lower range, maybe high hundreds of US dollars. When you start getting into the active exoskeletons, you're talking about computer control. You have to use design algorithms and in some cases artificial intelligence to adapt the system to who's wearing it. And those are where the expenses increase. So now you're getting into the tens of thousands of dollars per unit. And so when you measure that up against injury, you're talking about shoulder injuries, back injuries, knee injuries. All the joint injuries tend to be expensive, and they tend to be chronic. So shoulders, as you injure them, they tend to get injured again, and it becomes redundant, unfortunately. And so you're talking hundreds of thousands of dollars in US dollars per injury for shoulder injuries, back injuries, and knee injuries. And those are the significant joints that we see injured. And you compare that up against one unit of an exoskeleton, that might be, let's say, $5,000. You can see the comparison.
I understand the use, or I assume that using the exoskeleton to reduce the force applied through the joint, or maybe the rotation of the joint, or whatever the story is, that makes sense to me. How do you manage things like repetition? Because obviously tissue will ultimately fail with repetition. Yeah,
that's absolutely right. I mean, just like any mechanical device, it has a life cycle. You can only do so many repetitions until the device fails. What's unique to people and biological systems, as you know, is the healing factor. So as long as you stay within a capacity of healing and you don't exceed that, then it can repair itself naturally. And so the idea with the exoskeletons is to buy people time. And so when we're looking at passive devices, the posture assist systems, they only augment a portion of the mass or a portion of the weight of the individual, of that limb, of that torso, of that joint. And so that idea is basically stretching out in an anti-fatigue fashion, stretching out that risk. So instead of you taking on the burden of 100% of that risk, it's now shaving off a portion of that risk. And now that remaining portion, you can stretch out over time. And that's why we tend to call them anti-fatigue devices, because what we see up front when people use them is, okay, your discomfort decreases. The immediate effect is discomfort decrease and fatigue decrease. You notice that right off the bat. The lagging effect is, of course, injury, which takes time to accumulate and come on time. And so what we like to say is, it brings risk down. It doesn't remove risk totally. There's likelihood you can still develop an injury over time. But what this is doing is buying you time and stretching out that exposure level so that hopefully you have more years ahead of you than you had without.
That's a valid point, because labourers obviously might peter out in their 40s, really, but we might be able to at least get them to their 60s.
Exactly.
That's really interesting.
Because the repetitions and the hazards are still there. If you have to put 100 holes into an aircraft, drilling holes, that's not going anywhere. That's still a requirement of the product. But this just buys you more time.
I think I had thought that exoskeletons were being used to allow humans to lift something that a human couldn't normally lift.
Mm-hmm.
But I think I'm relieved, because that's actually not what you're saying. Do you use it, though, in any capacity like that?
Yeah, so material handling, manual material handling. So you're talking lifting, pushing, pulling, carrying, all of those are there. We are coming out of a phase where we have chosen 3 shoulder exoskeleton support systems to support our workers. So we're checking the box on shoulder systems and saying, all right, let's move on. Now we're in the phase of looking at hand exoskeletons to deal with really high repetition, large squeeze loads, all of those things, and then lower back exoskeletons for the material handling aspects. What we're starting to see, similar to what I mentioned before, the anti-fatigue effect is applicable there. Again, it only removes a portion of the risk. We have internal requirements. So, for example, lifting loads have to be 35 pounds or less. You can't exceed that. And when you do exceed that, we do make some room in there, some wiggle room, so you can have multi-person lifts, or you bring in mechanical assist devices, robots, whatever it may be. But in the end, we see these as still staying within the safe requirement limits of lifting, but stretching out that risk exposure as we explained earlier. Now, when you get into the strength systems, there are strength exoskeletons that companies that we've been working with, we've been, advising and consulting with them. Here's how you design for the people. Here's for our intended Boeing audience. We see them close. They're on the horizon. They are able to do intense augmentation. You're talking hundreds of pounds, where that's not safe at all for people to do without that. And so now we're talking about the human forklift scenario. When you blend that capability with a person, it brings on the sci-fi notions that we all tend to think about. And so we're close to that, but it's not here yet.
I was going to ask you about hands and fingers, because that's a very difficult thing. But of course, something that's an extension of your hand is going to get in the road in a confined area, especially if you were putting together, manufacturing the flight deck, so to speak. Mm-hmm. So are you able to tell me maybe what kinds of jobs you would, obviously drilling and things like that you've mentioned. Is there anything else that you can use that for?
Yeah, we've been slowly weeding out the likely scenarios that we would use it on. So one thing to note, just like any glove, you need to make sure it's sized properly. Unfortunately, there are limitations in the design of the gloves where, you get into the extremes of the spectrum, either too big or too small, where those people tend to get weeded out, unfortunately, and the gloves aren't available. So we're still working with the suppliers and the manufacturers to increase that spectrum to allow for more versatility across size and shape. But once you get the size and shape down, what we're looking at is you have the trigger opportunities, like you mentioned, for hand tools. So 1 or 2 trigger or full hand, all 4 finger trigger. Then you have the grasping opportunities. So our injuries for hands tend to be in high repetition, high force grasping. So you can think of things like wire bundling. So aircraft have miles and miles of wires throughout the infrastructure. It's just part of kind of like how we have veins and arteries and nervous system. It's how you function. And so putting that inside aircraft, wiring that and threading that is very hand intensive. You could be thinking of something as small as threading a needle with a small wire, or something like massive, large bundles that you can imagine going through the large sections of aircraft. And so that is really hand intensive. And so that's one of the areas that we've defined for continued study. We're continuing to observe them in those areas. It's not that great, at least the current hand exoskeletons, they're not that great at fine dexterity tasks. So if you ask them to type on a keyboard, assemble a Lego set with small little pieces, most of the time folks take them off. It just gets in the way. They lose tactility, they lose dexterity. And so what we're finding is this is good for gross capability when you need some large hand grip, large loads.
Yeah, the tactile feedback was what I was thinking would be a problem. It's interesting they take them off. What kind of feedback do you get from them? Do they wear it for a while and then they're really not interested? You may have said this at the outset, but I'm just sort of thinking, given the development of the exoskeleton and the different tasks for which they've used, are you finding that it's a love-hate relationship?
That's a great way to put it. It is. So a lot of times we drop exoskeletons in there, and we call it the honeymoon phase. So you just got married, you have your partner with you. Now you guys have to live together. How do you get along? And that first couple of months is that it's really integral to the relationship. And so what we tend to see is whether you like it or hate it, that immediate exposure to the exoskeleton changes. So after 2 months, after 3 months, you're either inherently loving it more or loving it less. And a lot of times you see people flip. They go from, I never wanted this to begin with, but now I love it, and then vice versa. And so I'd like to say that with just like any PPE, you need time exposure to get used to the equipment, customize it to your body, customize it to how you use it and how you work. And that just naturally takes time. The other things I think about is if we look at, let's use seatbelts, for example. When seatbelts first came online, it took decades before people naturally adjusted to using them. You jump in the car, you immediately put it on nowadays. How was that in the 1960s or 1970s? There are actually exoskeletons that precede me. There's some already in Boeing, Australia. And so I need to go check on them and see what's going on. I know some of my compatriots in Australia are looking forward to seeing me at the event. So we're all going to get together and have a great time on the Boeing side of the house. But at the same time, I'll see what I can do to ship some over, and maybe we can do some show and tell as well.
I believe the Exo Games were recently on in the UK. So look, tell me about that. What was it about? What were you doing? What happened?
Oh, man, the Exo Games were crazy. So the idea of the event is how do you create a STEM activity for university students around a new technology, emerging technology like exoskeletons, and then perpetually do that over time. So 2023 was our break-in year. We solicited to the world, to all the university systems, hey, if you're interested in doing this and getting involved, here's how you do it. The idea behind it, ASTM, as I mentioned, F48 is a committee on exoskeleton standards. They have a center of excellence called the Exo Technology Center of Excellence. It's one of two centers of excellence, the other being on additive manufacturing. And so the Exo COE put together this event to promote the technology, the research to standards effort. And so here you have these universities that design their own exoskeletons for 4 different challenges. The challenges being the ability to get up and walk around and sit down. We had actually a bomb removal challenge for a real world challenge. Not a real bomb, mind you, it's just a demo, a show. And then we had a manual material handling challenge where they picked up large crates with weight. And then you had an agility challenge, which was a cup stacking or de-stacking competition, just to see how the interfaces with the hands. We had 5 teams that ended up, there were originally 7, but unfortunately due to changing circumstances, we reduced to 5. So we had 2 teams from the United States, we had a team from Belgium, a team from Brazil, and a team from England. And so it was an intense challenge because not only did we have to evaluate the performance and efficacy of the system, is this thing going to kick it in the real world, kind of kick the tires, but also encourage these really enthusiastic students that this is an opportunity for them. This is actually something you can go into when you graduate. You can go into mechatronics. You can go into human factors and ergonomics. These are areas that you can go into and invest a career in. And it was just completely mind-blowing, completely fascinating working with these students, working with my colleagues. I'm looking forward to actually next year to see how we do this again.
Wow, how exciting. I imagine that the feedback from the students was amazing. What kind of things were they saying?
So as any kind of engineer, you can imagine, okay, what did I do wrong and how do I fix it? So they're coming at you with, all right, how do I change this? What are your recommendations for that? How do we tweak the system? They're looking at iterative design inherently. How do they make the next one? And I really enjoyed that. Those conversations, getting into the science of things, because many are coming from backgrounds that have no human factors or ergonomics understanding. And then you have others who have great understanding in human factors and ergonomics, but maybe not so much on mechanical engineering or product design. And so in the back of my mind, I almost wanted to merge teams together. Like, you have a good strength here, you have a good strength here, come together, form the Justice League or the Avengers, and you guys can take on the world. And so it's just amazing getting to speak with them. My colleagues, coming out of Northern Illinois University with Professor Don Peterson, and Verts, who's coming out of the National Institute for Standards and Technology. You had University of Central Lancashire, so Matt Dickinson was there, and then Dr. Bill Balot was out of ASTM Center of Excellence. All of us coming with different strengths. And I couldn't have asked for something better. I was completely surprised on how well it went.
I know that the Human Factors and Ergonomics Society in Australia has been looking at ways to connect with early career people, but I hadn't thought of doing that. Clearly, there's a lot of preparation that's had to go into that because they've had to design the devices they're working with.
Yeah, it was crazy because we gave them requirements based on ASTM standards and said, here are the requirements that you have to meet. And so they actually met the requirements. I mean, you're talking about designing things from scratch. And they had, their CAD drawings. They had all these things they're bringing, bill of materials, how much things cost. So we based it on a $2,000 US limit. It can't exceed that in cost. And so you had some on the really low end looking at how do you make a sustainable device that can be used for people who may not have financial ability. And so some are on the really low $100 end, and then some were edging up closer to 2,000 as you got into more sophisticated electronics. But it was fabulous.
Well, I'm looking forward to hearing what happens with the next one. I guess are you likely to do it again?
Oh yeah, we're looking forward to 2024. The idea here is we're going to create what we call challenge rooms. Essentially, we're thinking of 6 to 8 different scenarios ranging across real world situations, from construction to manufacturing to emergency response to healthcare, all these different realistic situations. And then you design an actual room that they would work in that environment. And so from our end, the developer side of the house and the judge side of the house, it's going to be really difficult bringing that realism to bear. Right now, we're also trying to figure out, where are we going to hold the event? This one was in England. Should we come to Australia, for example? Would the Australians put us up for a great competition in a show? These are all things that we're trying to figure out at the moment.
Thanks for joining us at the Human Factors and Ergonomics Hub, brought to you by the Human Factors and Ergonomics Society of Australia, where human-centred design really matters. If you like this podcast, make us your favourite in your podcast app. We look forward to chatting with you next time.